Now that we have seen some example, let's talk about what's inside table constraint. So the algorithm behind the filtering mechanism. Let's first introduce some terms. We are going to talk about tuples. A tuple, it's a line within the table, so a given association of value for the variable. And the tuple, they can be valid or invalid. It depends on the current value inside the domain of the variable. So for example here, we have some domain, 1 and 2 for x, 1, 2, 3 for y, and 1, 2, 3 for z. So for example, this tuple, it's still valid. Why? Because 1 is still in the domain of x, 2 is still in the domain of y, and 3 is still in the domain of z. This tuple, for example, it's not valid anymore. Why? Because, well, 3 and 3 for y and z, it's still in the domain, so for these two variables it could be possible, but we have here the value 3, which is not in the domain of x. So it only takes one value not happening anymore to make the whole tuple invalid. We also have what we call the supported literals, which is another term that we will need. And a supported literal, it's one value for a given variable, and it's supported if there is at least one tuple within the table which is valid. So it's in fact a value that can still be a solution, because only the valid tuples can be solution. So here, as 1 for x is still in the domain and it's still in one of the valid tuples, then it's a literal that is supported. And there can be values inside a domain that are not supported if there is no more tuples in the table that are valid. So for example, you can see here that Z3 is still supported. We have 3 tuples with Z3, but Z equal 2, it's not supported anymore because we had one tuple here, and it's not supported anymore because of the 4, which is not in the domain of x. So Z equal to 2 is not supported anymore. And so what do we need to do with this value of 2 in Z? Well, we need to remove it, because a solution can only be part of the table. So if a solution is only part of the table and the valid tuples from the table, then there is no way we can have Z equal to 2, because there is no remaining valid tuples which can allow that. So Z equal to 2 should be removed from the domain of Z, which is what we call the filtering of the unsupported value. We remove all the unsupported value. And so how do we do that? Well, the naive way, it's inefficient, but it's the naive way to understand what we do. We will just try for each of the variables, for each of the values of these variables. So we are going to test all the values in each of the variables, and we are going to look if there is no more tuples, so it doesn't exist any R, the row, where we have what we call a valid tuple. So here we look, we are going to check for all the row. For the row that have value still in the domain of the other variables, and row that are the value that we target for the given variable that we target. So in fact, it's the row that are still valid and that have this value associated to this variable that we are going to check. And if we don't find any more of these rows, so if we don't find any valid tuples that support this value for this variable, then we are going to remove the value from the domain. So this is what we call the filtering. And in MiniCP, well, you have the implementation, the corresponding implementation. So what are we going to do? We are going to check here for each variables. We are going to check for each values that are still in the domain. So in practice, there is a small implementation details, because here we are checking for all the values between getMin and getMax, but if you have sparse domain, so domain with hole in them, so not all the values are present between the mix and the max, then you should just iterate on this one. But here, it's a small hypothesis that we do. So we will check. So we check here, in case we have a sparse domain, we can still do that, but we need to check if the value is in the domain. And then we will check, do we find something that is, do we find a support? So do we find a valid tuple that have this value? And so we will check, well, for each of the tuples from the table. So we are going to check all the tuples. We are going to check if the tuple have this value, this target value. Why? But if we check the one that doesn't have the value, it doesn't suit the problem. So we are going to discard the one that doesn't support the value. And we are going to check, so the one with the value. We assume all is supported for a given tuple. And we are going to check if the other values of the tuple are still in the domain of the other variables. If there is at least one that say no, the value is not in the domain anymore, so the tuple is not supported anymore, so it cannot be a support for the given value that we are testing. And so if we find at least one tuple that supports the value and which is still valid, then we can say that it's possible we have a value and it's okay. And if not, of course, we remove the value.